thing to be a vector. Okay, is my screen visible to you?
Yes, sir.
And now the rule lines, you can see it?
Yes.
Okay, okay. So we'll start from here on. Yes. So we had discussed in the last class that vector is actually a quantity which have both direction as well as the magnitude. And yes, that was a sufficient thing. But we had also mentioned that there is something else missing here. This. Okay. So we'll start the thing from here only. And today we'll try to cover at that extent that we should complete that fill in the blanks. That was something else written there. Okay. So yes, so today first thing that we should write here is about the representation of the vector. You should have a copy and pen with you. Okay, I'm reminding you again that you must write it now, whatever I'm writing here over the board. Okay, so we have a representation of a vector. We are seeing that how we can represent a particular vector. So actually, there are two methods to represent a vector. One is the analytical method. Do you know what is the meaning of analytical?
Uh, Analyzing the parts of.
Yes, exactly something like that. Okay, so analytical means that we'll see that how we can represent a vector by writing it. Okay, in words. Like we can represent a vector like by writing the complete word vector. But is there any other different notation by we can definitely say that this quantity is definitely a vector? Okay, so we'll see that particular one notation also here. First one is will be the analytical method, and the second one will be the graphical method. Okay. So first quantity that we will write here is the analytical method. How we used to represent the vector in analytical method? We used to write it, the represent the vector by a bar over that particular thing. How we used to do that? We used to do that by presenting a bar over that, okay, with a
Okay.
arrow over a word. What we should write here is by putting a arrow over it. Okay, by putting an arrow over it. For example, let's say there is a vector. Let's name it as A. So how we can say it? We can say it that this is the letter A, but now we are not sure that whether A is a vector or not. But if we place a small bar over it like this, okay, understood? A small arrow, somewhat like this. So now we are sure that yes, A will be a vector. Understood? Are you sure about it? Are you okay with this?
Yes.
Yes. Now, if we are putting a bar, that means we are definitely sure about it that yes, it is a vector. Okay. What else we can say? For example, we can also write it like that. This OP. OP is also a vector. Okay. So just if a bar is placed over it, so that will be called as a vector. And one more representation is also there, which rarely some books follows. But I'm discussing the theory over it, so that's why I'm writing it over here. But we can never write it with the pen because that representation is called the representation with the bold letters. Okay, it is represented by bold letters. What do you mean by the bold letters? A bold letter just means that what we are doing, just for example, if I need to write A, so I'll write it somewhat like this with the bold letters. Okay, so this is that it will become very tedious for to represent it. So that's why we'll never ever going to follow this particular one notation. Okay, so this is the analytical method of writing a particular vector. Understood?
Yes.
Okay. Second is its magnitude of a vector. of a vector. We know that vector contains of two particular things. One is the direction, another one is the magnitude. Direction is, for example, we are saying it that it is pointing towards the north direction, it is pointing towards the south direction, it is pointing towards the east direction. So this is what, this is the directional part which we are saying. For example, the second thing that we are saying is that we are applying the force. So force will definitely have some magnitude. Okay, so if we are saying that 10 Newton force, so 10 is the magnitude. Understood?
Yes.
So magnitude is just the number that the quantity. Okay. So magnitude of a vector, for example, if I'm saying that what I'm saying, let us say that A is a vector that is the 10 Newton. That means it is a force in east direction. Okay. Understood? So this is the vector that we are saying. East is the direction. What is this? This part is called the direction. It is having the direction, and 10 Newton will be called it as its magnitude. This will be called as its magnitude, and what it is the direction. Understood? So
Yes.
what is the easy way if we don't know about the exact magnitude? If I'm saying that A is the vector, what I'm saying that we are saying that A is what is if I'm representing it like this, that means it is a vector. If I need to represent the magnitude of A, so what will I do? I'll put it in between two bars. Okay, what does this mean? It means magnitude of vector A. Magnitude of vector A. Understood? Because vector A will definitely have two things associated with it. One will be the magnitude, another one will be the direction. So if I'm writing it between the two bars, so that will be called as magnitude of vector A. Or there is a one more easier way for to do this, because see, we humans always try to write the things in as easy way as we can. So we had, these are something that we had already done, and now we are just copying it from our ancestors, that they had done us, they had said us to follow this particular convention, and we are going to follow this particular thing. So magnitude of A will be, can be represented like this, that we need to put that vector in between two bars, or we can say it just A. Understood? So we can also say it like if just A is written, so that will be also uh, read as that it means that we need to know about the magnitude of A only. Understood?
Yes.
Okay. For example, if I'm writing here, so what will be the value of A? If I'm writing A is the 10 Newton in each direction, so what will be the value of A?
10.
A will be 10. Okay. So this is the something that we need to write here. And more specifically, I should write 10 Newton here, because that should contain the magnitude, should contain the unit also. Okay. Magnitude contains of unit also, that what I'm talking about, is it the meter or Newton or whatever it is. Understood?
Yes.
Okay, so the second thing that we are going to do here is, we had seen the analytical method. The second thing that we'll see here is, will be the graphical method. We'll see the graphical method. What do we mean from the graphical method? That means now we are no more no, we are no more concerned about the letters, or we are with the writing part. We'll see just by the diagrams how we can represent the vector. So by diagrammatically, it is easier. We used to represent it with a arrow like this, with a arrow like this. So this is how a particular vector is being represented in a graphical method. Understood?
Yes.
Okay. And what else we can write here? We can also say that, let us say that this is the point E and this is the point P. So because so this is the vector pointing from point O to point P. Understood? Yes or no?
Yes.
This portion, this backward portion is called the, this portion is called the tail of vector. This portion is called the tail of vector. Understood? And this portion is called the head of vector. Understood?
Yes.
So if we need to represent this particular vector in analytical method, how will we write it? We'll write it just like this, OP. Understood?
Yes.
Okay, okay. So this was the thing that how we can represent the particular vector in graphical method. Okay. Sorry. Now we'll write some what we used to say, that is the properties of a vector. Of vector. What do we mean by the properties of vector? That what are the properties that this particular vector used to follow? Understood?
Yes.
So first thing, the property of the vector is that vector remains unchanged if we shift it parallelly. Understood? What do we mean from this? For example, if I'm drawing the vector somewhat like here, okay? And what else I'm doing here is that I'm just shifting it. What I'm doing? I'm just shifting it like this. Okay, I'm shifting it upward or I'm shifting it downward. Can you see that how I'm shifting it?
Yes.
This shifting does not lead the vector to change. The reason behind this is on shifting, it is still pointing in the same direction. Can you see this? That I'm not rotating it. I'm not changing the direction here. Okay.
Yes.
So that means a vector remains unchanged if shifted parallelly. Understood?
Yes.
For example, I'm just shifting it to this point. Okay. So what we can write here is that a vector remains unchanged. A vector remains unchanged if shifted parallel to itself. Understood? So that means, for example, let me take some, draw it here. For example, I'm drawing the one vector to be here, another vector to be here, and let's take, draw the another vector here. Okay, so what we are doing, we are just shifting this vector in a four different places, but each time it is pointing in the same direction. It is pointing in the same direction. So what we can say here is the vector remains unchanged even after the shifting it like this. Understood?
Yes.
Okay. So this is the one of the property that we used to see, that vector remains unchanged even after the shifting of the vector. Okay.
Yes.
The second thing that we used to see here is the parallel vectors. Parallel vector is a very easy thing, can be understood by the name that if two vectors are parallel to each other, then that will be called as a parallel vector. Okay, understood?
Yes.
If they are parallel to each other, what does that mean? That they are having the same direction. Yes or no?
Yes.
So what we can write here is two vectors having the same direction, having the same direction will be called parallel vectors. Parallel. Understood? So let us draw it here. For example, I'm drawing it here. Control V. And I'm drawing it here also. Okay. So this was the thing that we had. This will be called as a parallel vector because they are parallel to each other. Okay. Understood? They're having pointing towards the same direction. So then that will be called as a parallel vector. Understood? The third
Yes.
thing that we used to see is the anti-parallel vector. Anti-parallel vector. What does this do we mean from this? Anti-parallel means we easily see this. This is a very something we can understand from the name only. Anti-parallel means they are parallel but pointing towards the opposite direction. Okay. In that case also the two lines will remain parallel. But as they are pointing to opposite to each other, that's why they will be called as anti-parallel vector. Okay. So what we can write here,
Yes.
two vectors having opposite direction are called anti-parallel vector. Anti-parallel vector. Understood? So how we can draw it? We can draw it somewhat like, for example, if one vector is pointing towards this direction, so another vector should be parallel to this particular vector, but it should point in the opposite direction like this. Understood? Can you see this?
Yes. Yes.
And instead of this vector, I should draw it manually. Okay, so this will be called as a parallel vector and this will be called as a anti-parallel vector. Okay, understood? These are the very easy things that we can understand just by the names. Okay, now it
Yes.
is the important thing that we are going to see here is equal vectors. Now see, now it is very important thing, equal vectors. Understand the thing that what is vector? Vector is having two things. What are those two things?
Magnitude and direction.
Magnitude and the direction. So if I'm saying two vector to be a equal vector, I'm saying I had given you two vector, one is vector A and another one is vector B. So if those two vectors are equal, so they should be equal in both the things. One is the direction, another one is in magnitude also. Understood? We
Yes.
cannot say that if a 10 Newton force is applied in a north direction and a 10 Newton force is applied in the east direction, both will be same. No, they will not be same, as they are having the same magnitude, but the direction is different. Understood?
Yes.
So what we should say here, that two vectors are said to be equal in their magnitude as their directions are same. Okay?
Yes.
Two vectors are said to be equal if their magnitude and directions are same. Are same. Understood?
Yes.
So see, now you will understand the thing that why I had redrawn this parallel vector. In parallel vector, they were having the same direction, but see, these two vectors are not equal. You cannot superimpose one over the another. Can you see this in parallel vector?
No.
If you will superimpose, what do I mean from the superimpose? I mean from the superimpose that if I place one over the another, you will never find that they will become equal. What will happen? That they will not become equal. Understood? They are having the same direction, but their length is different. Okay?
Yes.
But in equal vector, what is going to happen? Whatever the magnitude, whatever the direction I'm taking here, the same direction should be taken like this. Okay? Understood? Equal vector means
Yes.
that if we superimpose one over the another, we'll see only one of the vector. For example, like this. If I superimpose one over the another, what will I get? I'll get a single one vector, which I was not getting in the case of parallel vector. Understood? So equal vector, just remember the thing that equal means that it should be equal in both the things, magnitude as well as the direction. Understood?
Yes.
Okay. So the second thing that we should see here is the negative vector. From the name only we can understand that negative vector means that they should what do I mean from a negative vector? That if I had taken a one vector, if I place a minus sign in front of it, that will become a negative vector of that. Okay, so that means the direction should be opposite only, and the magnitude should remain same. So what is said? Like we can say that two vectors are said to be a negative vector if they are having the same magnitude but opposite direction. Okay, so what can I say? Two vectors are said to be negative vector if they have same magnitude but opposite direction. Understood? So this will be called for a negative vector. Understood?
Yes.
So if we want to draw it graphically, how will we draw this? We'll draw this somewhat like this. That this is the vector A having pointing along this direction. So another vector should be opposite to this. Okay, and exactly opposite to this. Okay, so this is how we used to draw the negative vector. Understood? Is this all clear to you?
Yes.
Okay. Second thing that we should see here is that scalar multiplication of a vector. Scalar multiplication of a vector. What do we mean from the scalar multiplication? For example, that let's say that there is a particular vector here. Okay, let's say that I'm drawing the vector here. Okay, let me draw it here only. Okay, before this, I think I should tell you one more thing. Then we'll see the scalar multiplication. Before this, I should write a point here in the note. Magnitude of vector is directly proportional to its length. Okay, understood? What do you mean from this? That the length, the higher, the longer the length of the vector that I'll draw, its magnitude will be larger. Understood? For example, let me give you an easy example for this. Let's say that this is a particular vector here. Okay, and let's say there is another vector also here. Okay, I'm naming this particular vector as A, and I'm naming this particular vector as B. So if I need to see that whose magnitude is greater, so whose magnitude is greater, A or B?
B.
The magnitude of vector B is greater. Or can I write it also like this?
Yes.
Yes, because the magnitude can be represented by that alone single letter also. Okay, so this is how that we used to see that if we are drawing a vector of a larger length, so that will be of the larger magnitude. Okay, understood?
Yes.
Okay, now we'll see the scalar multiplication of a vector. If we are saying that the scalar multiplication of vector, that means, don't you think that if there is a vector, let's say 10 Newton, 10 Newton in each direction, I'm just considering it randomly, that there is a 10 Newton vector in the each direction. So yes, it is having both the things, magnitude as well as the direction, yes or no?
Yes.
Yes. Uh, if I half the vector, what I'm saying, I'm just reducing it to half of its quantity. Then what will be what the final vector will become?
Half of the previous vector.
Half of the previous vector. Yes, that's a very correct answer that you had given. Half of the previous vector. But what will be the magnitude? If I had taken the 10 Newton in each direction. So what will be? And I'm reducing it to half of its value. Then what will be the final thing that I'll get?
5 Newton in each direction.
5 Newton in each direction. So have you realized this? That while reducing the vector, you had not taken care of about that what the direction is. Direction will remain same, only the length will be reduced of the vector. Yes or no?
Yes.
Yes. So that means scalar multiplication does not changes the direction. Yes or no?
Yes.
So should I write the first point here that it does not changes the direction of a vector? Okay, because you had answered it yourself that the final vector will become 5 Newton in the each direction in the same direction. So that means it's does not changes the direction. But if we but that means if I was saying it to you that reduce the vector to half. So can I say it also like that multiply 1 by 2 with that vector?
Yes.
Yes, I can say the same thing because the same thing is going to happen if I say it to you that multiply that vector with that half 1 by 2 because you will do the same thing. You will just so that means the scalar that I had chosen in this case is 1 by 2. Yes or no?
Yes.
And as I am multiplying this particular 1 by 2 with the vector, the direction is not changed. So that's why I had written that on scalar multiplication of a vector, it does not change the direction of the vector. Okay, just a second.
Yes.
Okay, so that means we had concluded one thing that it does not change the direction of the vector. The second thing we had, I think, also had concluded it that it only affects the magnitude of the vector. It only changes the magnitude of vector. Understood? Yes or no?
Yes.
Okay. So we had seen these two things that on scalar multiplication, uh, only one thing is going to happen that it does not change the direction of the vector. It only changes the magnitude of the vector. But uh, we had concluded this for till now. Okay, let's see that have we written it correctly or still some amendment is required there. Okay, if it is required, so we'll do it that itself. Okay, now tell me one thing that if I'm representing a particular vector like this, okay, this is A, and I wish to draw a 2A, then what will I do? I'll draw the vector pointing along the same direction, but of the double length. Yes or no?
Yes.
So this will be called 2A. Yes or no?
Yes.
But what if I wish to draw a vector of minus 2A? Do you agree that its length will be increased to 2 times? Yes or no?
No.
Uh, it's if I'm drawing, I already have a vector A and I wish to draw a vector minus 2A. Okay. So what will be the magnitude of minus 2A? First of all, tell me. This will be nothing but 2A. Because in
Yes.
magnitude we don't care about the sign or direction, we just need to know about that particular one quantity. Okay, so
Yes.
and in A the magnitude of A will be simply A. So don't you think that we had
Yes.
increased the magnitude with 2 times?
Yes.
So that means if I have a vector A and I wish to draw a minus 2A, that means the first thing that I need to do here is that I need to increase the length of the vector by double of its length. Yes or no?
Yes.
Yes. But what this minus sign is doing here, what this minus sign is doing here, don't you think that previously to whatever the point A was pointing, now this is pointing in opposite to that particular direction? For example, what if I say this to be A, I'll say that this is minus of A because it is pointing in the opposite direction. And that's why I had set this point at this at that particular discussion of the negative vector that I had just placed the minus sign in front of it. Yes or no?
Yes.
So negative vector means that we had just placed the minus sign. And in fact, for showing a vector in the opposite direction, we used to take the help of this minus sign. Whenever we need to point the two vectors which are having the opposite direction, one will be represented with the plus sign and the another will be represented as a minus sign. There is no convention that I should say minus to this only. I can take this as a plus A and this as a minus A. No issues with that. But one, if I had chosen one to be a plus A, it's my responsibility that the another vector that I should choose here is should be minus A. Understood?
Yes.
Okay. So do you let me correct it first of all. This is minus A and this is plus of A. So and in fact, no need to keep this plus sign here. Okay, this is minus A. So that means if I'm doing the scalar multiplication with a negative number, so that means I'm changing the direction also. Yes or no?
Yes.
Can you understand this or you are having some confusion in it?
Uh, your video was slow.
My video was slow. Is this now okay? Is that now okay?
Yes.
Okay. So now tell me that if I'm multiplying this to be A and this to be 2 times A, so that will be pointing along this. But if I multiply this A with a minus 2 sign, then I'll get a vector pointing along this and this will be called minus of 2A. Yes or no?
Yes.
So what was the scalar while I had chosen to draw from A to 2A? What was the scalar quantity that I had chosen here?
2.
I had chosen the 2 here. And what was the scalar quantity while I need to draw this particular vector I had chosen?
-2.
Negative 2. So do you agree that on the basis of the selection of the scalar, we can change the direction as well? Okay, so direction of the vector on doing the scalar multiplication can be changed, but it depends that what scalar are we choosing. If we are choosing the positive scalar, the direction will not change. But if we are choosing a negative scalar, that means the direction will change. Yes or no?
Yes.
So that means the first point which we had written here, it does not change the direction of the vector. Is this correct? This is not correct. The correct statement will that it may change the direction of a vector. Okay. Okay. Is this clear to you?
Yes.
So is now the scalar multiplication of vector is very clearly understood by you?
Yes.
Okay. But remember only this two things that on doing the scalar multiplication, we can get only one of the two things. We can get either the vector that is pointing along the same direction or the vector that is pointing along the opposite to that direction. None other vector can be obtained. Okay.
No.
The third point that we can write here is it produces only parallel or anti-parallel vector. Yes or no?
Yes.
Do you agree with me over this third point that it can produce only the parallel vector if the when the vector will be the parallel, what the scalar should be?
The scalar should be
Positive. Yes or
positive. Yes.
yes. If the scalar is positive, then that vector will be called as parallel vector. So in the small points I am writing here that if scalar is positive. And before writing that, first of all, let me write it properly. That and let me make it generic. That I should not take a specific number 2. Let me take k here. Yes or no? Let
Yes.
me take the number to be k and minus of k. And instead of here, I'll get minus k, and instead here, I'll get k. Yes or no? Is this now became more generic and not specific for a particular value? Is this okay?
Yes.
And it will produce a parallel vector when k is greater than 0. Yes or no? And anti-parallel
Yes.
vector when k is less than 0. Is this okay? Understood by you
Yes.
clearly?
Yes.
Okay. The next thing that we should study here is the null vector. What is the null vector? Null vector is null means what? What do you what can you understand from the word null?
0.
Yeah, null vector is its magnitude is 0. Only this is the condition. Its magnitude is 0. And can you now understand that if its magnitude is 0, so its direction, you can't define its direction. Yes or no?
Yes.
For example, if I say that I'm applying a force of a 0 Newton, so in whatever the direction I may apply, it doesn't matter. Yes or no?
Yes.
Yes. So this was the some of the nomenclatures and some of the things that we should, some of the properties actually, and this frequently used to the examination is asked by the examination about that what is null vector, what is parallel vector, what is anti-parallel vector. Sometimes the questions used to be framed by the examiners somewhat like this, but these are no more anymore conceptual, not any kind of a conceptual vector. But yes, this scalar multiplication of the vector was one of the important thing that we had seen here in detail. The null vector, its magnitude is 0, and the second point that we should write here is that it do not have direction. Its direction is not defined. Okay, so its direction is not defined. This was the thing, and the second thing that is the one of the important thing, that is the angle between the vectors. Angle between the vectors. Now, what is going to happen that I'll provide you the vector, and our aim is to find the angle in between them. Okay, understood?
Okay.
Okay, so we will what the things we are going to have here is that we'll have some vectors, and we need to find out the angle in between those two vectors. So how we are going to do that? So we'll see it here. Okay, so angle between the vectors. See, whenever Uh, first of all, we need two vectors for this. Okay, we need two vectors. Understood? So the first thing that we are clear about, that we'll have the two vectors, and we need to find out the angle in between them. Yes or no?
Yes.
Okay. So now how we are going to do it? See, whenever and we are going to use the graphical method here, graphical approach here. Okay. Most yes, definitely only the graphical way is only the way that we are going to understand here for to find out the angle between the vectors. Sorry. If we have two vector, so some arrows are given to us. Yes or no?
Yes.
Okay. You are very clear about it that yes, some arrows will be given to us and we need to find out the vectors. Acha, tell me one thing. Can we shift the vector parallelly without changing its direction?
Yes.
Yes, we can do the shifting because it is being allowed to us that you can shift the vector. Just only take care of the one thing that don't rotate it, don't change the direction, and don't change even its length also. You can just shift the vector as much as you can, and wherever you want to take the those vector, you can take it with you, but never ever change its direction. So yes, we got one thing that we'll have the two vectors, and we can shift it as wherever we want. So, and yes, what are the two extreme points on a vector? One is named
The
as yes,
head of the vector and the tail of the vector.
yes, head and the tail. Yes, we have got one thing that vector have two things. One was the called as the head of the vector. Another one is called the tail of the vector. Now, how we are going to do this? See, we have two approaches, but I'll discuss only one here, and I'll tell you about the other. I'll not discuss even that because we'll never ever going to use that, and you will find that no one is using that particular thing. See, but I'll tell you definitely because if the question is mean to discuss about that particular point, so you can answer that. Okay, so we have two vectors. We can shift them as much as we want, and we have 2 points located over the vector. One was called as a tail, and another one is called as a head. Okay, so how we'll do that? For to find out the angle between the vector, just join the tail to tail. Understood?
Yes.
What you have to do, you have to join the tail to tail vector, and whatever the angle you will get between the vector, just answer. Oh, acute angle. Okay, remember this, the acute angle, because what why I'm saying this now, I think I'm in a position to write here something over the board. Let's say that we have two random vector. I don't know about these two vector, that what are these. The somebody came and gave me that this is vector A and this is vector B, and somebody said that find angle between, I'm writing this as a between, okay, A and B. Somebody said to me that go and find out the angle between the vector. So whatever we had discussed here, we'll do the same thing here. Okay. So what we'll do here is that we'll take this B and we'll start moving. Okay. Because we can shift it without changing its direction. Yes or no? Yes or no? Can we shift this
Yes.
vector without changing its direction?
Yes.
Yes. Okay. So we can shift it. And what is required here is that we should join the tail to tail. Can you see this? That I had
Yes.
joined the tail to tail. Okay, we had joined the tail to tail, and now whatever will be the acute angle between them, because I had joined it, so two angles are being formed there. One is this, and the second one is this. Yes or no?
Yes.
Can you see this? That we have two angles formed here. One is this, and the another one is this. One is the acute angle that I'm talking about, and the another one angle here is this angle. This is also one of the angle. But we not need to take this particular this angle. We need to take care of the acute angle, the smaller one always. Okay. So this theta, let's say this is an angle theta. We don't know about that what the actually angle is. We'll say that this is the angle between A and B. Understood? Understood?
Yes.
Yes or no? Okay. So what we need to do this, that the first thing that we are doing here is join tail to tail, tail to join uh, tail to tail of vector. Okay. Now, if you'll join tail to tail of a vector, what next we have to do? We have to report the acute angle between uh, A and B will be called angle between the vector, angle between vectors. Understood?
Yes.
Is this clear to you? That what is required by you is that join the tail to tail and you will get the vector. So I think I should remove this orange one. Okay. So this will be theta will be called as and this, and what we had got here, the theta will be called as a vector. Understood?
Yes.
Okay. So should I give you some questions here?
Sure.
Okay. let's say that you have this vector, and this is the vector that I had taken here. Let's name it as O A. Not A. I think I should name the individual vector as A. This is vector A. This is vector B. This is vector C. Okay. Now you just need to find out. Okay, one more information is given that magnitude of A is equals to magnitude of B is equals to magnitude of C. That means what kind of figure it is? Is it a known figure?
Equilateral joint.
Yes, equilateral triangle, exactly. Or else I can also write it as A equals to B equals to C. I can also equivalently write it this. Okay. Now you need to find angle between first part is A and B. The second part is B and C. The third part is between C and A. Find these. Sorry.
Angle 60 degrees.
What are you saying about A and B? You are saying A and B to be 60-degree. Okay, I'll write your answers here. Then B and C. But see, always follow the same thing that I had told you. That join tail to tail, and whatever the angle that you find there, just report it.
All three angles are 60.
All three angles are 60. Are you sure about it?
Yes.
Okay. So should we start the solving here? I'm writing your answers here, and let's see. Let's see that what happens. Okay. You had said that all three angles are this. Okay. Let's see. Uh, I think A and B are very easy one because they are already drawn in a very systematic manner that A and B are having an angle of 60-degree in between them. Yes or no?
Yes.
So I think for the first part, I should simply write that it will be a 60-degree. No issues with that. Yes or no?
Yes.
Now the second question comes. Second question is asking for B and C. Okay. So uh, have you joined the tail to tail of B and C before answering 60
No.
degree? Have you joined? But I had said you one thing that whenever you need to find out the angle between the two vectors, the first thing that you need to do is join tail to tail.
The tail
So
is
it is
not
not. Yes. What
joined
are you
in the
saying?
figure,
Hmm.
but we can shift it.
Yes, exactly. You have the liberty to shift it. So how can you do this? Let's see. Let's do it. Okay. Let's copy this figure and let's paste it here. Only. Okay. So now we are in a trouble that first of all, I think I should remove this particular part of A because I'm concerned about only B and C. Yes or no?
Yes.
Okay. As you had said me that I can remove A, so I'm removing. Now, what is my aim here is to find out the angle between B and C. Okay. Uh, okay. I think I should do one more thing. I should do one more thing that I should join this particular this with a reference line that whenever something will come, I'll mark this to be a 60 degrees. Yeah, I know as it is an equilateral triangle. So these all angles will be 60 degrees somewhat. I know it very well. Okay. So I'm just writing it here. Yes, all these angles are 60 degree, but I'm not sure about that what C will make with B. So we are concerned about that only. Okay. Now
Yes.
let's see that let's take this C vector and shift it parallelly. Okay, okay. What I'm doing here is, can you see that I'm shifting it parallelly?
Yes.
Okay, so I had just shifted it to this particular point. Okay, I had shifted this to this particular point, and I think I should shift it a little. Okay, let me see that I can do anything. Yes, now I think it's correct. It's totally okay. Okay, so what I'm doing here is I'm writing this to be C vector. Is this okay?
Yes.
So this should be the angle between C and B. Yes or no?
Yes.
And how much this angle will be equal to? As we don't know about it, so let's see. Let me see. Can I find it out mathematically? What I'm doing here is I'm just drawing the previous C that was drawn initially here. I'm drawing it as it is. Okay. Now tell me, if I had shifted this parallelly, so this is parallel to this, and uh, so don't you think that if this is parallel to this, so it forms the co-interior angles that we had seen somewhat in class 9th and 10th? The sum of these two angles is always equal to 180 degree. Yes or no?
Yes.
Because if we have two parallel lines and a line somewhat like this, this angle and this angle, these sum it will always equal to 180 degree. Yes or no? Have we seen this before also? This is called the
Yes.
interior angle on the same side of the transversal, co-interior angles.
Yes.
So can you tell me now that what will be this complete angle called? This complete angle will be equal to,
120.
that will be 120 degree. So yes, this is the correct answer here. Uh, okay, so this will be 120 degree. So and why I'm writing 180? I should write 120 here. Okay, so the answer of B to C part will be equal to 120 degree. Okay, so do you want to give a try to a third one, C and A by yourself?
Sure, sir.
Okay, find out the angle between C and A. Do the same thing, that first of all remove B if it is not of our work, and then try to find it out. Just take care of one thing, that we need to shift the vector parallelly without changing its magnitude. Okay, and once you had given your try and you had even if you had not got the answer, then also no worries for that. Just tell me, so then I'll discuss it here.
Is it 60?
Yes, you are right. Okay, how will we do this? Uh, See, first of all, B is not required for C and A. So first of all, remove this. Now what is required, that we can shift the C. So if you had already found it out, so uh, let's not do it like this. What I need to do here is that mm, I need to shift the C. So what will I do? I'll just shift this C from that point to this particular one point. Okay. So that will be somewhat like this. Okay. Let me again use the eraser here. And okay. So that will be the C. And if we
Excuse me, sir.
see it, yes, sir.
How
Yes,
long
yes,
is this
yes.
class?
How long? This is still what time had been told to you?
I had not been given an ending time.
Okay, so it will be till 7:30 only, but more preferably we for class 11 or 12 we used to take the class of 1.5 hours, because in that we get a sufficient time for to cover a particular one topic. But the timing for this class is 7:30, but for today I will extend it a little more. Okay,
Okay, sir.
this is 60 degree. Okay, so this is 60 degree. Understood? So yes, your third part was correct, but I don't think that you had used this analogy for to find out the answers. Understood? Should we move ahead?
Yes, sir.
Okay. Let me write A here properly. Okay. So is this part all clear to you?
Yes, sir.
Okay. So this is was the complete part till today, and actually, have the team told you about the diagnostic test?
No, sir.
Okay. So I'll tell you about it. See, whenever anyone new joins this particular one platform here with us, we used to take the diagnostic test. And that test is not of anything of class 11th will be asked to you. All the things that you had completed in class 10 only require to uh, you'll get the questions over that only, and that is not even that is not that hectic thing that you should take it that you have to do all the questions and everything. Whatever you know, whatever the answer that you know, you just answer it to me, and based over that we used to plan your strategy that how we are going to move ahead. Okay, so actually our whole team is being established for this, and that test is even being designed by us only, and you have to give it. Okay, so I'm just presenting the questions in front of you. You just have to do it by yourself, each question one by one. Okay, in the class here only. And
Sure, sir.
can I see you on your camera? Is your camera working?
Sure, sir.
Okay. Okay, so can you see this test?
Yes.
Okay. So this is not the only one question. There are others also. I'll just copy paste it here so that you can solve it. These all tests are designed as per your class 10th grade. Okay, nothing of class 11th will be asked to you. And do it as much as you can. And if you want, even if you want the help in any one of the question, you can ask it to me. Okay,
Sure, sir.
like in equation or something that you want any kind of explanation in any question, you can ask it to me. I'll provide it to you. No worries for that.
Okay, sir.
But do it as much as you can, so that we can see that how we should move ahead with you. And do you know Hindi also, or
No, sir.
you don't know Hindi anymore?
No.
Okay, okay, no issues with that. You can start doing the question. If you stuck in any of the question, you want the explanation from me, I'll explain it to you. And if you even if you want to leave the particular one question or something, that you can leave also. Okay, and try to do it fast as you can. Kirasha, once you start getting the answer, just tell it to me. I'll write here over the board in front of you only.
Sure, sir.